set for probability. Okay, before that, please take note the exercise that I already give to you, okay, yesterday in the Padlet. So, correct soalan apa ya, Lokman ni? Sekejap. Ada satu tu soalan in the exercise question number 3 tu. Okay. Dia punya last tu lah ada tersilap sikit dia punya class interval tu. Okay. So question number 3, I think question number 3 should be the last class interval should be 40 40 less than equals to x less than 45. Okay. So that one. And then satu lagi soalan nombor berapa ni? Ada satu lagi yang typo tu. Okay, nanti kamu check lah
Nombor 4.
Nombor 4 Soalan nombor 3 dengan soalan nombor 4 Betul?
Betul.
Saya stop dulu lah. Okay, so question number 3 and question number 4 Okay, so hopefully everyone already have the group for the assignment. Okay, kalau tak ada, cuba carilah member team of the group tu. Sebab kalau tak salah saya, you all ada total 44 students. Okay, so should be cukup lah kalau 4 orang satu group tu. Okay, so kalau tak ada, cuba tengok dalam tu. If you already upload lah tengok yang mana yang ada kosong tu. Okay, so for that one is for your assignment. Ya?
Mau tanya sikit boleh?
Boleh.
Kalau group data,
Okay.
mod dia ada dua frekuensi yang ada dua kelas mode yang macam mana cakap? Frekuensi dia
Highest frequency lah. Okay, dia tulis
ada dua.
yang group data tu.
Kena macam mana nak buat nak kena
Tak pasal. Ada soalan nombor apa tu buat Lokman?
soalan nombor
Sekejap saya share balik kalau let's say ada soalan.
Soalan nombor 4 lah. Soalan nombor 4.
Nombor 4 Sepatutnya tak ada kotlah saya ada typo kat situ.
Mod ni yang paling banyak frekuensi bukan yang sama
Highest frequency. Dah highest frequency.
Oh lah, okay, sorry. Salah baca. Sorry. Maaf, okay, sorry.
Betul
Betul. Sorry.
Sepatutnya kalau macam group data jarang lah kita bagi yang ada dua-dua. Okay, tapi kalau untuk yang for ungroup tu tu biasalah. Memanglah ada yang ada the same mode dia hanya frekuensi tu. Okay. Sebab dia kalau konsep dia sebenarnya kalau highest model, okay, kita ada unimodal. Okay, unimodal maksudnya univariate. Okay, kalau bimodal actually dia ada macam dua peak. Okay, biasanya kalau macam rainfall kan, hujan, okay, taburan hujan. Okay, so kalau taburan hujan sepanjang tahun lah di Malaysia, dia akan ada dua peak sebenarnya. Okay, dua bimodal, biasanya bimodal rainfall pattern is depends on the location of the station. Okay, katakan biasanya kalau dekat west, okay, western, okay, west coast lah ataupun pantai barat semenanjung Malaysia. Pantai barat semenanjung Malaysia especially area macam Subang, Seremban ataupun area Johor Bahru tu, not Johor Bahru lah, Subang, Seremban ataupun Ipoh kat atas tu, biasanya kita ada bimodal rainfall pattern. Okay, biasanya dia ada highest rainfall dia akan berlaku dalam 2 season, biasanya dalam waktu intermonsoon. Okay, April to May tu biasanya dia ada highest peak and then satu lagi between September, October. Tapi kalau macam taburan hujan di Pantai Timur, East Coast, itu dalam bentuk unimodal. Okay, unimodal maksudnya either November, December ataupun Januari. So itu sebab dia bersambung sebab kamu ada rainfall kat Malaysia ni is very influenced by the monsoon lah. So kamu ada north east monsoon and also south west monsoon. So that is how kita interpret kita punya dataset. Okay. Okay, again for today's class, we go for set and probability. Okay. Okay, so again in chapter 2, so this one is on the topic of probability. Okay, in Malay we call this one as kebarangkalian. Okay, so again, first we state the definition of probability. Okay, so kalau probability je maksudnya is a numerical measure, something that you can compute. Okay, a numerical measure of the likelihood of the event. Okay, dia punya value, likelihood kejadian sesuatu peristiwa, apa kebarangkalian kebolehjadian sesuatu peristiwa itu. Okay, that is a numerical measure of the likelihood of the event. Okay, chances that a particular event will occur. Okay, so dalam konsep probability, there is some terms that you need to know. Okay, proses yang berlaku adalah secara rawak. So we call this one as random experiment. Okay, so process by which an observation is obtained. So an experiment will result in different outcome. Okay, dia punya proses ya. So for example, let's say if you have this one, so this is called as random experiment. For example, tossing a coin twice. So it will result in different outcome. Tossing a dice. Okay, taking a driving test. So then kita adalah dia punya outcome dia. Outcome dia is the result of an experiment. For example, let's say we toss a coin twice. So kita ada dua kali lah. So that means it can be either head, so ish, head, tail, head, ataupun tail. So this is your possible outcome. So kalau ada dice, okay, dadu, okay, sebiji dadu di lambung. Okay, so kita ada outcome dia, either dapat nombor 1, 2, 3 and so on. So we have 6 possible outcome. Okay, so again, taking a driving test, either pass ataupun fail lah. Yeah. So itu basically proses, proses by which an observation is obtained. So an experiment can result in different outcome. So proses tu berlaku secara rawak, random experiment. So outcome, apa dia punya outcome dia? Result from the experiment. So kalau tossing a coin 3 times. So kita ada 3 kali lah pula. Either head, all 3 heads, ataupun all 3 tails, ataupun only 1 head, only 2 tails, and so on lah. So kita ada all the possible outcome there. So that is basically the definition random experiment and also outcome. So next kita ada sample space. Sample space sama juga, kita dah listkan all possible outcome. Cuma dia dalam bentuk set. Okay, the set, dia punya definition is the set of all possible outcome of a statistical experiment which we know as capital S. Okay, so for example lah, head, tail, head, tail. So first tu kamu define dulu. Katakan H ni nak pakai untuk head. Ini kita pakai untuk tail. Okay. So again lah, you have again set for 1, 2, 3, 4, 5, 6. Okay. So kalau event adalah a subset of a sample space. Apa yang kita nak cari sebenarnya? Event apa? Kita define. For example, let's say A, kita define lah. An event with 2 heads are observed. Maksudnya dalam set A ni kita ada head, set A. And then you can compute the probability. So for example, B. Okay. Even number is observed. Katakanlah kita ada dice tadi. So even number is observed. That means dalam set B kita akan ada 2, 4, 6. Okay. So itu event. Okay. Event. A subset of a sample space. So kalau sample space is a set that lists all possible outcome. Okay. So kalau event, apa yang kita nak cari? Apa yang kita define daripada peristiwa tersebut? Okay. Okay. So again, a technique. Macam mana kita nak establish dia punya probability dia? So again, first approach ataupun first method lah ya. So this one we use a classical probability. Okay, classical probability. So again, you have your S as a sample space, and then each outcome in S is equally likely to occur. Okay, kebarangkalian dia sama untuk dipilih. So katakan kita define apa event A. So you want to find what is probability of A. So the basic formula is just number of outcomes in A divided by number of outcome in S. Ataupun bilangan unsur dalam set A dibuatkan dengan bilangan unsur dalam set S. Okay, then you get your probability. Okay, itu very basic lah. Okay, for example, this one, 2 fair coins are tossed. Okay, maksudnya kita lambunglah 2 keping duit shilling. So again, when you list all the sample space yang tadilah kita ada, either it can be either head, tail, head ataupun tail. Okay. Okay. Ini kamu punya set lah. So list all possible outcome. So you want to find the probability that 2 tails are observed. Okay, kita nak define dia punya event dia. Katakan kita define lah event A tu. So event A is the event of 2 tails are observed. So you want to find what is your probability of A. So dalam set A, tak ada, ni je lah, TT. So again, you want to find your probability number of A divided by number of sample size. So again, sample size, sorry, number of sample space. So you have 1/4. Okay. So kalau ini, find the probability that exactly a head is observed. Exactly a head. So ini 2 tails. So 2 tails, you have 2 coin. So first coin is tail, second coin pun tail. So ini exactly a head, only 1 head. So it can be either, katakan kita define event B. So it can be either head tail or tail head. Okay, so the probability is just 2/. Okay, that is the probability of B. Okay, so itu kita menggunakan konsep dia adalah classical probability. Okay, classical probability. Okay, so ini just revision sikit lah daripada apa yang kamu dah belajar waktu SPM tu. Benda yang sama je, cuma akan ada sikit lah dia punya konsep probability later on lah. So awal ni saya rasa sama je kot dengan apa yang kamu dah belajar. Okay, so this is your classical probability. So again, number of outcome is A divided by number of outcome in sample space S. Okay. Okay. So let's say you have a fair dice. Kita ada dadu. Okay. Roll twice. 2 kali. Cuba listkan dulu all possible outcome. Bila kita ada dice. Kita ada ni, kita listkan dulu all possible outcome dia. Okay, so you have set S. So set S here. So you have dice. Okay. So it can be either 1, 1, 1, 2, 1, 3. Sampailah kita ada 5 and then 1, 6. Okay, repeat lagi. So kita ada 2, 1, 2, 2, 2, 3, 2, 4, 5, 6. Okay, sampailah kamu ada 6, 1, 6, 2, 6, 3, 6, 4, and then 6, 5, and then 6, 6. Okay. So kalau kita listkan all sample space, number of your sample space now is 36. All possible outcome. 6 kali 6. Okay. 36 all possible outcome because dice, kalau ada dice, kita ada 1, 2, 3, 4, 5, 6. Okay. So that's why kadang-kadang kita tulislah a fair dice. Maksudnya tak ada kepincangan, tak ada apa-apa lah dekat dice tu. So a fair dice, so kalau a fair dice should have all 6 observation lah. 1, 2, 3, 4, 5, 6. Okay. Now find the probability that the sum of the two rows is at least 10. Okay, kita katakan kita define set A. Okay, set A is an event that the sum of the two rows is at least 10. Sekurang-kurangnya 10. 10 ke atas. Okay, at least 10. Okay, cuba senaraikan dulu set A tu. Ada apa dalam set A dia? Cuba senaraikan dia punya kemungkinan dia. Okay, event that the sum of the two rows is at least 10. Okay, so kita ada apa? Okay, 46. 46, 64. Kita tulis dulu. Okay, 46. Okay, 64. Okay. Okay, apa? 56. Okay, 66. And then ada lagi tak yang saya tinggal? Okay, so you have 46, 64, 56, 65. And then kita ada 66 lah. Yeah. Okay, 55. Okay, 55. Okay, betul ya? So 6 all possible outcome. Okay. Okay, so again, you want to find your probability. So samalah ya. So probability of A, so just bilangan unsur set A divided by bilangan unsur set S. So you have here is 6 all possible outcomes. So 6 divided by 36. 6. Yeah. So that one, okay, probability that the sum of the two rows is at least 10. Okay. So that one kita listkan dulu, okay, define lah. Okay, let's say if you define set A ke set B ke, it's up to you lah which variable that you want to use. So set A event that the sum of the two rows is at least 10. Okay, it can be sekurang-kurangnya 10. So that means 10, 11, and the largest one is 12 lah. Yeah. So again, you have all possible outcome is 6/36. Okay, so 1/6. Okay. So itu kita menggunakan konsepnya adalah classical probability. Okay, classical probability. Okay, boleh teruskan ya. Directkan. Okay. So the next one is we call here is empirical probability. Okay, empirical probability. So kalau empirical probability, so lebih kurang sama juga lah macam classical. Cuma this one, kita the experiment trial is repeated for n times and it is observed that event A occurs for a time in this n repetition. So kita nak carilah probability of event A ni, maksudnya number of times that event A is observed divided by total number of repeated trials. Okay, berapa kali event A ni is observed divided by dengan total number dia. Okay, for example lah ya. Kita ada benda macam ni lah ya. Among 400 randomly selected drivers in the 20 to 24 age, okay, 136 were involved in an accident. So if a driver in that age bracket is randomly selected, so what is the probability that he or she will be involved in that accident? Okay, secara empiricalnya berapa? Okay, so for the same thing, kita ada total sama juga lah event A divided by total number dia. So again lah, cuma this one kita call sebagai empirical probability. Okay, number of times that event A is observed. So dalam case ni kita ada 136. Okay, so total number of repeated trials kita ada 400 lah. So in this case we just have 136 divided by 100. Okay, masih konsep yang sama. Okay, cuma this one kita call sebagai empirical probability. Okay, tapi dia punya calculation tu sama juga lah macam classical probability. Okay, cuma term yang digunakan dalam case ni adalah empirical probability. Okay, number of times that event A is observed divided by total number of repeated trials. Yeah, so itu secara dia punya calculation lah, empirical probability. Okay, so kita ada classical probability empirical probability, and then the last one you will have a subjective probability. Okay, so kalau subjective probability ni it based on personal punya judgment ataupun individual punya experience dan juga belief. Okay, for example, this one example are the probability of a tsunami will be happen. Okay, the probability that the price of petrol will increase again within the next 6 months, or the probability that FAPP will leave the collision. For this type of event, subjective judgment based on experience and frequently expert advice is used to estimate the probability. Okay, based on dia punya personal judgment ataupun dia punya experience lah. For example, Siu Ling has been a school counselor for almost 20 years. According to her knowledge, okay, 24% of her students have family problems. So what is the probability that a student randomly selected from her class do not have family problems? So dia punya complement dia lah. Sebab dia kata 24% of her students have family problems. So berapa persen yang tak ada family problem? So 100% minus 24. Okay, so we will get the answer. So itu based on her judgment. Okay. So again that one. So dalam case ni kita punya ni, kalau kita nak menjawab soalan dia 76% because ini kita tanya do not have family problems. Yang diberi adalah 24% of her student have family problems. Okay, kita tak ada concrete data, cuma based on her experience, mungkin sebelum ni dia dah ada data set, and then secara rawaknya, secara ninya, randomnya, berapa persen yang ada family problem. Okay, itu kita panggil sebagai subjective probability. Okay, chances dia. Okay, so that's mean for example lah, let's say katakan kita dah tanya experience of yang experienced lecturer. So what is the probability that the student for this subject will pass this subject? Okay, based on her experience, dia boleh estimate lah berapa persen. So itu based on dia punya personal judgment. Okay, so itu kita panggil sebagai subjective probability. So you will have a classical probability, you will have empirical probability, and also subjective probability. Okay, ini term dia. Okay. Normally, what we use normally is just a classical probability. Tapi dia ada juga term yang lain, which is empirical and subjective probability for your knowledge. Okay, for your own knowledge lah ya. Jadi ada beberapa jenis juga kebarangkalian tu. Okay. So that one. Okay, again, this one. Okay, classical. And then kita ada empirical, number of time that event A is observed divided by total number of repeated trial. And lastly, you will have a subjective probability. Okay, itu konsep dalam probability ya. Okay. Saya punya nota ni campur-campur sikit. Kalau campur, if you already have the module, okay, saya taklah follow everything in the module ya. Okay, itu just give you a roughly idea lah what is should be in the content for FSPM 0034 So yang setengah-setengah tu saya add on jugalah sikit-sikit Okay, so again you have here is your axioms of probability. Okay, so probability dia ada properties dia. So again your probability should lies okay from 0 up to 1. Okay, total probability equals to 0, that means that event will not happen. Kalau probability is equals to 1, it will for sure it will happen. Okay, so you only can have the value including 0 and 1. Okay, normally 0.1, 0.2 and so on. Okay, total probability must be equals to 1 since your total probability of your sample space is equals to 1. Okay, so ini kena make sure betul lah ya. So again, probability ni actually dia relate juga total area under the curve kadang-kadang lah ya. So if you further lagi, bila dah sampai ke tahap tinggi sikit, bila sama degree tu, if you integrate lah, okay, kamu dah belajar sikit kan calculus integration. Okay, kalau kita integrate, katakan lah ya, integrate anything lah from minus infinity, for example, minus infinity up to infinity, fx dx, okay, this will give you 1 actually. Okay, kalau kita ada total area under the curve. Okay, total area under the curve, the total probability is equals to 1. Dia relate balik pada konsep probability. Okay, so ini kalau kita relatekan kepada konsep mathematical statistic, kita ada integration. So if you integrate this one over the range yang kita punya ni function tu define, so it will give you total probability that is equals to 1. Okay. So complement rule of probability. Okay, ini katakan kita ada set A and also set A prime. So this is your set A, this is your A prime. Okay. So kalau kita ada list sample space S ni, dia akan listkan all possible outcome. Kenapa tak boleh pula join? Okay. Sekejap ya, kawan-kawan tak boleh nak join kita punya kelas ni, kenapa ya? Dah, boleh? Okay. Boleh, apa ni? Nawin. Okay. So again, so we just continue on. So again, the concept for axioms of probability. So you have total probability is between 0 and 1, including 0 and 1. So total probability of your sample space must be equal 1. So kalau kita ada complement, so kita define complement kita tu ataupun kita denote dia punya simbol sebagai A prime. Okay. So you already have your set A here. So yang tak berada dalam set A tu kita considerkan sebagai A prime. So kalau kita ambil probability A plus probability of A prime, it should give you total probability is equals to 1 since total probability of your sample space is equals to 1. Okay, kalau nak dapatkan probability of A prime, 1 minus je lah. Konsep dia 1 minus probability A. Okay, 1 minus probability of A. Okay, itu kalau kita nak dapatkan probability of A prime. Okay, so ini kadang-kadang kita panggil, mungkinlah dalam bahasa Melayu ni kita panggil peristiwa pelengkap kot, tak salah saya lah. Ya. Dia punya komen dia. So kalau A plus A prime, it give you total probability dia mesti sama dengan 1. Okay. For example, let's say task 2.1. Okay, task 2.1 in your module. So you have a fair dice is tossed. Okay, the event A is defined as getting a number divisible by 3. Okay, find probability of A. Okay, kita ada dice. So kalau dice, first of all, you listkan dulu all possible outcome. So kita ada set S. Set S, kita ada 1, 2, 3, 4, 5, 6. Okay. Event A, number can be divided by 3. So dalam set A tu. Okay, set A, so that's mean you just have 3 and 6. So you want to find your probability F A. So kita balik konsep dia classical probability. So altogether you will have 2/6. So it gives you 1/3. Okay, 1/3 ya. Okay. So itu first part. So kalau event B is defined as a number not divisible by 3. Tidak boleh dibahagikan dengan 3. So dia punya complement dia lah. Okay. So ataupun you can also list what is in event B. Ataupun you can use lah kita punya A prime punya konsep. So dalam case ni, probability of A prime is equals to probability of B. Okay. So again, you will have 1 minus 1/3. So again, 2/3. Okay. So itu dia punya peristiwa dia, complement dia. So sebab kita dah define event A, number can be divided by 3. Event B, dia punya complement, a number cannot not divisible by 3. So you can either list down what is in the set B, or you just take the complement of A. Okay. So that one for task 2.1. Okay, direct je. So again, what we use is a classical probability. Okay, classical probability. Okay, kalau kita tengok 2.2. Okay, you can read the question. So in here, a box contains 10 marbles, which 4 are blue, okay, 3 are red, 3 are yellow. So a marble is selected at random. Okay, biasanya kita ada perkataan ni lah. A marble is selected at random. So proses tu berlaku secara rawak. Okay. What is the probability of selecting a red marble? So altogether you have 3 red marble. So again lah, kalau kita nak define, so katakan kita buatlah R. R is apa? Red marble. Okay, event of getting a red marble. Okay, probability of R. So that means you will have 3/10. Okay. What is the probability that not selecting a red marble? So complement dia. So letaklah simbol R prime. Okay, R prime. 1 minus total probability minus probability of it. So you will get 7/10. Okay, so that one. Okay, so that one is your complement kita punya ni. Konsep dia complement of event A ataupun event yang kita define lah ya. So peristiwa dia. Okay, so again lah dia punya konsep tu still apa tu? Normally, yes. Okay. Normally, when we want to define, we already define that, for example lah ya, kat sini saya tak tulis pula. Okay, katakan R ni, kamu define dulu pun boleh. Okay. Event of getting red marbles. Okay. So, you want to probability of not selecting a red marble, so you can just define it as R prime. So that is understood lah, even though you didn't define what is R prime. Okay, because standard kita punya apa simbol ada prime tu untuk peristiwa pelengkap dia, the complement of the set. Okay. Okay. Ada soalan lain kah? Do you have any question? Okay, itu I think you setakat ni you boleh follow kuat ya, sebab ini kita just refer back on the classical probability. Even though probability during your SPM, I think form 4, form 5 kan, ada konsep probability form 4, form 4 mungkin dah start kan probability kan, form 4. Rasanya lah Okay. That one. Okay, then kita masuk sikit. Okay, kita start the probability tu, kita stop dulu kat situ. And then after we go for permutation and combination, okay, after we finish that one, we will go back to the concept of probability, where we have additive rule of probability. You will have a conditional probability, multiplicative rule of probability, and the last one we will have a Bayes theorem. Okay, so that one. So ini kita tengok dulu basic counting. Okay, counting techniques lah. Okay, dalam basic counting ni biasanya kita start lah dulu dengan multiplication principle, and then we will start with permutation and also combination. Okay, so again this one is your multiplication principle. So katakan kita ada satu operation, if an operation can be performed in A ways, and if for each of these a second operation can be performed in B ways, so how many ways can we perform that two operation? So how many ways? We use the multiplication principle, just A times B. So number of ways that we can perform both operation, the first and second operation is just A multiplied with B. Okay, so itu basic counting dalam probability. So we start with multiplication principle dulu. Okay, multiplication principle. So katakan A ways nak selesaikan first operation. Second operation B. So how many ways? So it just multiply lah. A times B. Okay. So next we go for definition for permutation. Permutation. So permutation susunan, lebih kepada susunan, your arrangement. Yeah. So if we look at the definition, so permutation is an arrangement of all or part of a set of objects where the order of selection is important. Okay. Kita susun arrangement of all or part of set of objects where the order of the selection is important. Dia punya tertib dia tu yang penting dalam permutation. It's quite, it's different from your combination. Okay, ini kita ada start dengan permutation. Okay, permutation is an arrangement of all or part a set of objects where the order of the selection is important. So kalau the order of the important, cara kita susun AB dengan BA. Berbeza, right? Okay, tapi combination dia sama. Combination AB, combination BA, benda yang sama. Tapi cara kita susun tu berbeza. So that is your permutation. Okay. For example, let's say you want to arrange 3 letters. Kita ada A, B, C. How many ways that you can arrange these 3 letters? Okay, cuba senaraikan dulu. Kalau kita ada A, B, C, cuba listkan apa dia punya possible dia. You can also write in the chat if you want, listkan dulu. Okay, kita cuba tengok. Okay, ni ada macam-macam jawapan, ada 6, ada 9. Okay. So the best way is to write out lah, listkan dulu apa possible outcome dia. Okay, kalau kita ada A, B, C. So kita ada A, B, C, B, C, A, okay, C, A, B, okay, C, B, A, di B kat depan ni. Okay, B, A, C, and also A, C, B. So actually you will have 6 possible ways how you can arrange these 3 letters. Okay? Ataupun ini nanti kita tengoklah dia punya basic formula je lah ya. Basic formula just n factorial. N factorial since we have 3 letters A, B, C. So you have 3 factorial. So it will came out as 6 possible outcome lah. Okay, 6 possible ways. Okay. Okay, so kita punya arrangement A, B, C. B, C, A, of course, difference. Okay, and then C, A, B, difference. From ini C, B, A. And then again B, A, C. And then ini kita susun pula A, C, B. So you have 6 possible ways how you can arrange 3 letters A, B, C. Okay, boleh ya? Ataupun the easiest way is to use 3 factorial. Okay, n factorial. Okay, how many ways that you can arrange these 3 letters A, B, C. Okay. So again, permutation relates to the act of arranging all the objects of a set into some sequence ataupun order. So a permutation is basically an arrangement of objects in a definite order. So kalau permutation of n different object, maksudnya kita punya ni tadi A, B, C. Okay, letter yang berbeza. Okay, n different object. So the formula is just npn. Okay, ataupun n factorial. So in your calculator pun, okay, kita ada simbol tu, you can press. Kalau inilah, sebab saya guna 570ms. So atas multiplication tu, you will have NPR. Okay, NPR. So you can press that one. So actually, okay. So kalau NPN maksudnya n factorial, n minus n factorial. So you have 0 factorial. So 0 factorial is equals to, so we only have n factorial. Okay, so this is the formula. Kalau kita ada permutation, so n different object, tak boleh objek yang sama. Okay, kita ada formula dia just n factorial. Okay. For example, in how many ways can the letters of the word world can be rearranged? Okay, first kamu identify. Different letter ke ada letter yang sama? So of course this one we have different letter. So kalau different letter is just have 5 define ataupun 5 factorial. So it will give you 120. Okay. So ataupun let's say I'm not sure how your during your school lah, macam mana cikgu kamu ajar, saya tak pastilah ya. So 4, 5. Boleh juga gunakan kefahaman yang kamu dah belajar dulu. Sama je. Okay. Kita apply baliklah kat sini. So untuk susun nilai yang pertama kita ada 5 cara. Okay. Yang kedua kita ada 4. Yang ketiga 3, 2, 1. So that's why 5 times 4 times 3 times 2 times 1. So you have 5 factorial ataupun 5 different ways, which is give you, sorry, not 5 different ways, 5 different ways to arrange the first letter. Second letter kita ada 4 sebab kita dah ambil 1. The third one 3, 2 and 1. So you have 120 ways. Okay, so 120 ways to arrange the letter of the word world. Okay, so kalau yang bawah tu berapa? Journalist. So how many ways? So kita ada apa? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you will have apa? 3, 6, 2, 8, 8, 0, 0. Okay, so that means you will have 10 factorial. So dapatlah jawapan yang Luqman tu tadi. Okay, 10 factorial. Okay, 10 factorial because different letter were used. Okay, different letter, then baru kita pakai formula dia n factorial. Okay, n factorial. Okay, so identify the number of ways that this letter can be rearranged. Okay. Okay. Okay, so di sini kita ada sikit formula. So you will have permutation of R object from N object. Okay, maksudnya kita ada N, kita nak pilih R. So the number of permutation of ordered arrangement of R object taken from N different and likely or non-repeating object is written by this. So kalau kita ada NPR, so N factorial divide by N minus R factorial. For example, from 5, you want to choose or you want to arrange 3 objects from 5 object tadi. So kita ada NPR. Okay. And then this value 0 is between R and also N. So kalau kita ada permutation of N different object, okay, tapi kita dalam N different object tu, it comprise of R1 identical object, R2 identical object, and also RK identical object. Maksudnya kita ada perkataan yang sama di dalam that one. So the number of permutation for n different objects, of which R1 identical objects of one kind, R2 identical object of the second kind. So this is the formula. N factorial, tengok semua ada berapa. So dividekan dengan perkataan ataupun letter yang sama. Okay, for example, let's see lah the word statistics. Okay, for example, the word statistics. That's an example lah kami. Okay, the word statistics. Okay, for example, the word statistics. So ada berapa tu? How many ways? Boleh kira tak? Kita ada statistik ada berapa? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Kita ada 10. Okay. So kita akan buat apa? 10 factorial. Okay. So divide dengan perkataan yang sama. S ada berapa kali? 1, 2, 3. So 3 factorial. So T pun ada 3. Right? Lagi boleh. I So I kita ada 2. Ada lagi tak yang lain? Tak ada kan? Statistics. Okay. So you have 3S, 3T, and 2I. So it will give you turn out, dapatlah berapa dia punya value dia. Okay. So itu maksud dia permutation of n different object, but it consists of R1 identical object, R2 and so on. So this is the formula. N factorial, total number semua, bahagi nilai yang word yang, sorry not word lah, letter yang sama. Okay, so 3 factorial for S, 3 factorial for T, and also 2 factorial for word I. Okay, so that one. Okay, ada apa-apa persoalan tak? Sampai sini dulu. Ni kalau laju sangat saya ni inform Okay, selang But I think I just, ini just revision, so tak ada something yang new sangat lah lagi Ini saya tak pasti kamu dah pernah tengok ke tidak yang ni permutation tapi ada objek yang the same thing. Okay, so ini statistics so you have 10 divide by 3 yang sama 3 for S, 3 for T and then 2 for I. Okay, so itu that one. Okay. Example 2.6. Example 2.6 in okay, so this one you have 4 alphabets to be chosen from A, B, C, D, E, F. So kita ada 1, 2, 3, 4, 5, 6. Okay, nak pilih 4. 4 alphabets are to be chosen from A, B, C, D, E, and F, such that repetition is not allowed. Then in how many ways it can be done? Yeah? How many ways it can be done? So kita ada 6, kita nak pilih 4. Okay, only 4 alphabet are to be chosen. So the first choice, it can be any of the 6 alphabet. So katakan kita ada 6 semua, tapi kita nak pilih 4. Okay, katakan kita buat macam ni. 1, 2, 3, 4. So the first, apa tu? First space. Okay, first ruang ni, ruang kosong ni. Okay, first alphabet to be chosen. Kita ada 6 semua. So dia ada 6 possible ways lah to be choose the first alphabet. Okay, second, tinggal lagi 5 choice je. Okay, the third one, tinggal lagi 4. Ini 3. So you can have this one 6 times 5 times 4 times 3. So it will give you the value. Or if you want to find using the formula, so it's the same thing if you write 6p4. Okay, so 6 factorial, 6 minus 4, so 2 factorial. So the same thing lah, 6 times 5, 4 times 3. Okay, so cancel out, it will give you the same answer, which is kat sini kita ada 360. Okay, good. Okay, so 4 alphabet nak pilih daripada 6 alphabet. Okay, repetition is not allowed. Okay, maksudnya kita tak boleh repeat the same alphabet. So dia akan berkurang satu macam tu lah ya. So you have 6, 5, 4 and 3. Okay, itu basic So basic permutation. So ini adalah NPR. Dia bukan identical tadi. Yang first ni. Ini bahagian ni. Okay. Okay, that one is example 2.6. Yeah, boleh faham this one? Okay. Saya punya exercise tu betul ke? Exercise tu kadang-kadang saya letak je nombor berapa tapi saya tak sure dia continuation ke tidak ke Okay, example is in the module. So exercise that I already add on lah sikit in slide. Okay. Okay, exercise 5 Okay, suppose you have been hired by Astro and part of your job is to determine the shows to be shown on Monday night. So there are 27 shows available and you must select 4 of them. So how many different sequence of 4 shows are possible? Okay, cuba buat. What is the answer? So you will write 27 P4. Okay, 27 P4. Okay. Okay, so the answer should be apa? 4 to 1, 200. Okay, yang lain dapat apa? Okay, so you get the sum result. Okay, so in here we just have 27. Okay. Okay, 27 minus 4, you have 23. Yeah, so the answer should be 4 to 1 to 1. Yeah, to directly. Okay, boleh ya? So itu adalah arrangement permutation. So when you have a set of questions, so please identify whether that question is designed for permutation or that question is designed for combination. Okay, dia ada dia punya, bila baca tu kamu kena tentukanlah permutation ke combination soalan ni. Okay, so in here how many different sequence, okay, turutan dia of 4 shows are possible. So that's why it's like you arrange that one. Okay, so again this one is used for permutation. Okay. 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 So 2.7. Okay, kita tengok dulu example 2.7 ni. Siapa yang ada modul boleh tengok dalam modul. Okay, so this one is example 2.7. So you will have here is how many even counting numbers can be formed from the digit 4, 5, 6 if no repetition is allowed. Okay, maksudnya kita tak repeat benda yang sama lah ya. So kita ada 3 digit, kita ada 4, 5, 6. Okay, so kalau digit, okay, you have numbers lah ya. Okay, so you have the digits is 4, 5, 6. Okay, so you want to form even counting numbers. Okay, maksudnya bilangan genap lah, even counting numbers. Okay, but again, no repetition is allowed. Okay, so that's mean if we start, okay, by writing ataupun by determine for a single digit. Okay, single digit. So kalau kita ada 4, 5, 6, yang even numbernya hanyalah 4 dengan 6. Okay, only 4 and 6 can be considered. So you have number of single digit, even counting number dia 2 lah. So it can be either 4 ataupun 6. Okay, 4, 6 ataupun 6, 4. Okay, so you have 2 possible lah. 2 possible ways to arrange that one. Sorry, 4 ataupun 6, sorry, single digit. Okay, so again, that one is 2. Okay, next for a 2-digit counting number. Okay, 2 digit. Okay, so 2-digit counting number, we can only consider here. Okay, for 2-digit counting number. So for 2 digit, it can be either, sebab kita nak even. Okay, even number ya. So ending dia tu must be even number lah ya. So you either have 46, 64, ataupun 54 ataupun 56. Okay, for 2 digit. Okay, for 2 digit ya. Okay. So here again you only have 2 alternative how many possible ways? You only have 4 possible ways. Okay, sebab kita nak ada 2 digit ni. Okay, digit pertama, digit kedua. Okay, yang digit kedua tu dia mesti even number. Okay, so dia ada 2 choice dia, sama ada yang ending dia dengan 4 ataupun endingnya dengan 6. So kamu ada 2 possible ways. Okay, kata inilah first 2 possible ways. Okay, so dah fix ini, ada lagi berapa nombor yang kita boleh letak kat depan dia? Ada lagi 2 lah, sebab ini no repetition. So it can be either 4 ataupun 6. Okay, ataupun kalau macam ni lah, kamu ada ini, kalau kita dah letak sini 4, sini satu lagi 6 lah. Right? Okay, maksudnya kalau 4 kita dah fix lah. Hanya satu cara nak letak 4, nak letak 1. So lagi 2, it can be anything. Ataupun ini ini dah letak, okay, 6, hanya satu cara nak letak nombor 1 tu. Nak letak nombor 6 hanya satu cara je. So tinggal lagi 2. So you all together you will have 4 possible ways. Okay? So itu untuk 2 digit. Okay, 2 digit counting. Ataupun senaraikan lah. Pun boleh jugalah. So you have 4 possible ways to arrange that one. Okay. Finally, for 3 digit. Okay, 3 digit maksudnya kita ada 3 space. 3 digit. Okay. Yang last tu mesti even number. Okay, sebab kita dah consider even counting numbers. So it can be either 456, 546, ataupun 564, ataupun 654. Okay, so dia dah fix lah here. Okay, so 2 ways to select the even number, either 4 or 6. So 2. Okay, lagi 2 lah nombor yang kita boleh pilih. Okay, darab 2. So yang first tu tinggal hanya satu cara dia nak pilih lagi satu nombor. So you will have 1 times 2 times 2. So all together you will have 4. So the total number that we will have for even counting numbers is just 4 plus 4 plus 2. So all possible ways you will have 10. Okay, total number of even counting numbers. Okay, kalau odd different pula lah. Dia punya ni value dia. Okay, so ini adalah untuk even counting numbers. So it can be either 4 or 6. So 2 possible. So cuma sebab dia tak cakap berapa digit, kita tak fixkan. So that means we can start with a single digit. Okay, how many ways to arrange for single digit? For 2 digit macam mana? For 3 digit macam mana? So last total up semua. How many ways that you can arrange that one? Okay, boleh that one? Boleh faham tak example 2.7 ni? Okay. Okay. Okay, kita tengok example 2.8 So example 2.8 lepas tu kita break sekejap lah. Okay, tekak lah. Okay, example 2.8. Okay. So ini kita nak susun number of odd 3 digit. Okay, 3 digit counting numbers. But dia ada syarat dia pula. Less than 700. Okay, less than 700. So again, kat sini dia cakap repetition is allowed. Yang tadi tak allowed. Okay. So tu kena tengok jugalah daripada soalan So again, normally kita mention lah sama ada repetition ataupun tak ada repetition. So kalau ada repetition maksudnya kita boleh ulang balik dia punya nombor. Okay, itu je lah dia punya difference dia. Okay, kat sini kita ada odd 3 digit. Okay, kalau soalan yang tadi, dia tanya macam ni je. How many even counting numbers can be formed from this digit? Okay, dia tak tanyalah 3 digit ke 4 digit ke, tak ada. Okay, so ini already specific. Nak 3 digit. Odd 3 digit counting numbers. Okay. But again, syarat yang keduanya less than 700. Okay, less than 700. Okay, example 2.8. Less than 700. Okay, repetition is allowed. Okay. Suppose that we have 3 digit odd number that are less than 700. Katakanlah kita denote 3 space. Okay. X, Y, Z lah dalam case ni. X, Y, Z. Macam tu. Okay. So for the last third digit, okay, sebab kita nak odd. Okay, so digit ni kita ada apa? So 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so kita nak odd number. So odd number kita ada 1, 3, 5, 7, 9. So 1, 3, 5, 7. Okay, that one. Okay. So kita ada 5 possibilities 1, 3, 5, 7, 9. So kita ada 5 possibilities. Okay, that one. So for the second digit, okay, third digit kita ada 5 possible ways lah. Okay, 5 possible ways. Okay, katakan letak di sini lah 5 possible ways. Okay. Whereas for the second digit, we may have all possible digit from 0 up to 9. Because why? because repetition is allowed. Okay, repetition is allowed. So altogether you have 10 possibilities from 0 up to 9. So that's why yang kedua ni dia ada 10 possible ways. Okay. Okay, finally untuk yang first digit tu, syaratnya less than 700. So number yang paling hampir pun mungkin 699. Okay, sebab dia nak less than 700. Okay. So again, so less than 700 we can only have sebab first apa tu? First digit ni. It cannot be 0 lah. Sebab kita nak 3 digit. So itu dah out. Okay. But kita nak less than 7. Less than this one. So yang tinggal 6, 5, 4, 3, 2, 1. So all together you will have 6. 6 possibilities. So how many? So 6 times 10 times 5. So all together you will have 300. Okay, 300 possible ways to arrange this one. Yeah. So again, first identify dulu. Apa yang kita nak cari? Kita nak cari number of odd tapi dia beri 3 digit. Okay, and then second condition, less than 700. So digits from 0 up to 9. Okay, again, yang third dia ditulis kat sini, repetition is allowed. So you have to check lah that one. Okay, macam mana kita kondisi dia. Okay, so all together here is just 300. Okay, so soalan ni dia boleh manipulate macam-macam lah ya, bentuk untuk ditanya. Okay, so again, that one is again how the arrangement take place. So again, this one is belong to your permutation. Okay, sebab kita deal dengan arrangement. Okay, so that one for example 2.8. Okay, example 2.8. Okay, ni saya tunjuk dulu. Okay, cuba fikirkan macam mana kita nak selesaikan ni. Task 2.6 ni. Okay, cuba dulu ya. Kita break sekejap ya for 5 minit, 11, apa ni? 11.40 nanti kita sambung balik. Okay. Yeah. So again, this one. So again, kita dah ada even for digit. So again, consider less 8,000, between 8,000 and 8,500. Okay. So the first row kat sini, okay, ruang kat sini, first space tu. So kita consider sebagai even 4 digit number. So kita ada all together, fix lah, 5 ya. Okay. And then the same number can be repeat on the next and so on lah. Yeah? So it can be anything. So we'll consider between 0 and also 9. Okay, 0 up to 9. Kita ada 10 possibilities. Yeah. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can repeat that one. Okay. So untuk ruang yang kedua kita ada 10. Untuk ruang yang ketiga pun you can repeat again 0 up to 9. So, we have 10. Okay. Yang ni, yang first ruang ni, 7. 7. Okay, because we consider less than 8,000. So, it cannot be 0 kat sini. Tak boleh. So, you only have 1, 2, 3, 4, 5, 6, 7. So, 7 choice. So, 7 times 10 times 10 times 5. Okay, so ini kita dapat 3500. Okay, this one. Okay, next consider this one pula. Okay, good. Okay, consider this one pula ya. Okay. Okay, so sama. Ni 5 sebab kita ada even number, kita ada 5. Okay, second row ataupun second space. All possibilities value. Okay, so mungkinlah the nearest value, mungkin boleh tulis dulu lah 8499 katakan. Okay, that one. Okay. Sorry, 8499. Kita nak odd number, sorry. Okay. Okay. So anything lah yang kat belakang tu. Okay. So kalau paling dekat dengan dia 8 lah kalau kita ada dia punya nearest value, right? Okay. 8498 lah kalau let's say that one. Okay. For example lah ya. So, but again, yang kat belakang ni kita nak even number. Okay. So, again, you have 5 for the first space, ruang kat sini. So, you can repeat again. So, you have 10 possibilities from 0 up to 9. Okay, the third one. Okay, the third one. Sebab dia antara 8,000 dengan 8,500. Okay. So, kurang daripada 5 lah. Yeah. So, kurang daripada 5. So it can be 0, you can consider. So 0, 1, 2, 3, 4. So altogether you will have 5. Okay, boleh ya? Sebab kalau paling ni 4 kan? Okay, but you can consider 0 sebab kat tengah 1, 2, 3, 4. So you have 5 possibilities. Okay, yang first one kita fix lah 8. Okay, 1. Okay, the only way you can arrange 8 is only one possible ways lah. So again, you have 5 times 10 times 5. So 250. So altogether 3500 plus 250. So again, you get 3750. So this is the answer. Okay. The possibilities you can have if 3750. Okay, kita tak boleh nak buat secara direct. Okay, you need to split because you have several things to be considered. Okay, so the easiest way, if you can split, okay, less than 8,000. Okay, then you consider between 8,000 and 8,500. Okay, so state lah, kita ada 4 digit. So 4 digit. Okay, untuk less than 8,000, you only have for even number, kita ada 5 possibilities, itu fix. Okay, second, you can put anything because repetition is allowed, so 10 possible ways. Third pun, 10 possible ways, kita boleh repeat. Cuma yang first ni, less than 8. So you only have 7 because we already exclude 0. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, that one first. Second, you consider between 8,000 and 8,500. Okay, so again, fix ruang yang pertama, 5 number of even. Okay, so and then kita boleh repeat balik. So from 0 up to 9, so 10. Okay, yang kedua, okay, kita nak antara 8,000 sampai 8,500 ni. Okay, kurang daripada 5. So, but again, we can put 0 here. So 0, 1, 2, 3, 4. So 5. Okay, yang kat depan tu 8 je. Satu je. Satu cara je nak letak nombor 8 tu, satu cara je. So that's why we fix 1. Okay. So 5 times 5. So 250. So altogether 3750 is. Okay. Boleh? Okay. Kalau okay. Sekejap ya. Kalau tak consider repeat ketiga. Saya rasa kalau untuk soalan mungkin kita very detail lah kot ya. Apa Afrina? Kita akan letaklah repetition supaya yelah nanti nak menjawab pula soalan kamu kalau WhatsApp pula. Okay, ini repetition ke tidak? So saya rasa for our test ataupun test lah ya. For our test should be consistent lah. Biasa kita akan letaklah repetition. Okay. Okay, ada apa-apa lagi soalan pergantian ni untuk task 2.7? Okay, sebab dia saya pun tak ingat. Bukan tak ingat. Saya ada, ya.
Saya dapat 4249.
Auto format, boleh cakap macam mana cara kamu buat?
First saya cari single digit, ada 4 saja possibilities. 2, 4, 6, 8.
Okay, kejap. Okay, single digit tu, tapi kat sini dah state tau 4 digit. Lokman eh?
Ya Allah, saya okay, sorry.
Okay, kalau yang tadi, ya betul Lokman. Yang tadi saya tak state. Okay, kamu baca betul-betul ni. Dia baca soalan betul-betul lah. Dia kadang-kadang list mistake je, sayang kalau salah. Okay. Okay, that one Jaya. Dan satu lagi ya, kalau let's say for those yang dah ada modul tu, sebab kadang-kadang saya pakai, saya refer juga modul yang lama, so mungkin saya punya nombor example tu dah berubah dalam modul tu, mungkin lah ya. Saya tak perasan juga kadang-kadang tu. Okay. So kalau macam saya soalan daripada modul memang saya state out lah modul punya soalannya. Ini yang tadilah example 2.9. Sekejap ya. Sebab ada soalan yang ditambah juga. Okay, tak apalah, kita go through sekejap ya. Nanti kita akan ada sikit lagi lah additional exercise lah juga Okay, by this Thursday lah kot saya akan bagilah beberapa soalan untuk permutation ni before kita betul-betul masuk combination sikit lah after that. Okay. So ini yang soalan tadi lah sama je. Example 2.9. The word statistic ni tadi kita dah buat So kita ada 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tadi. 10 factorial bahagi dengan ni lah. 3 factorial, 3 factorial, 2 factorial. Okay, because we have the same word for S. Okay, T. Kita juga, okay, I tadi 2. Okay. So exercise. Okay. So you have 20 students. Okay, 20 students have appeared in a test in which the top 3 will get a prize. So how many possible ways are there to get the prize winners? Okay, so kita ada 20, kita nak pilih top 3. So the best way is 23 lah. Sebab itu lebih kepada arrangement. Okay, so maksudnya kita dah susun first, second, third arrangement. Dia bukannya combination. So again, as I remind, so read the question, distinguish whether this one is designed for combination ataupun permutation. Because dalam test nanti bercampur-campur tu kena ingatlah. Okay. So okay lah 20. Okay. Ini apa? 20P3. So 20P3. So you get 6840 Okay, ni pun sama If there are 9 cars in a race, in how many ways can they place first, second and third? Okay, apa jawapan dia? Simple je. So kita ada 9 cars in a race. How many ways can they place first, second and third? So what is one answer? Okay, 504. Okay, good. So 93 Macam ni direct je lah tak ada. 93, 504. Okay. Okay, this one. So let's see, Arif want to change his password, which is AA, RI, FF, 8. Okay. But with the same letters and numbers. Okay, cuma susunan dia yang berbeza kan? Betul tak? Okay, in how many ways he can do that? Okay, so this one is also permutation. Okay, arrangement. Okay, dia nak tukar dia punya password. Password ni lah. Okay. Tapi menggunakan letters yang sama, numbers yang sama. So how many ways he can do that? Okay, cuba dulu. Okay. Right. Okay, dah ya seperti tadi. Yang the rest. Okay. Okay, mostly dapat 1260 Okay, kita ada kat sini. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, 7 factorial. Okay. Okay, 7 factorial. So kalau perkataan yang sama, kita repeat A ni ada 2 kali. So 2 factorial ya. F pun ada 2 kali. Okay, dia bukan divide by 4, boleh lah divide by 4 lah ya, bukan 4 factorial lah tadi siapa jawapan tadi. Okay, sebab A 2 kali, F pun 2 kali. Okay, itu kalau we can arrange this one. Okay, betul jawapannya 1260, tapi dia tolak password ni. So tolak 1. So jawapan dia akan jadi 12. Okay. So dia tak nak lah password ni lagi. Itu je lah triknya. Okay. 1260 tu betul dah. Ini kiraan kamu kat sini. Tapi tolak 1. Okay. Boleh faham dia punya soalan tu? Itu je trik part dia. It's not direct lah. Dia implicit sikit je dia punya tu. Okay. Tapi dia taklah soalan kebat pun ya. Biasa je lah. Soalan biasa je. Okay. Boleh? Okay. Okay, ada apa-apa nak tanya tak soal yang berkenaan dengan ni? Yang kita punya exercise. Ini semua mostly task di dalam modul ya, sampai kalau ikutkan dalam ni task 2.2 apa ya? Tadi 2.10 Okay, 2.10. Okay, belum masuk combination ya. Combination nanti next class lah ya, saya masuk. Okay, cuma kat sini. Sekejap saya stop sharing this one. Sekejap, ada tak? Sekejap ya, sekejap. Okay ya. So again, sepatutnya kita punya kelas ni sampai 12.30 je. Ini, okay, kamu screenshot dulu. Okay. Okay, dia still permutation ni sebab ini soalan ni saya combine dengan bila saya buat tutorial sebenarnya. Okay, so mencari dia punya slide tak jumpa. So I just found this one. Okay, kamu screenshot dulu. Okay, this question. So this is I'm not sure whether you already came across this kind of question. Okay. So boleh cuba dulu. Ini contohnya lah, in how many different ways can the letters of the word optical be arranged so that the vowels always come together. Macam mana pula bentuk dia arrange. Okay, kalau yang kedua tu, in how many different ways can the letters of the word mathematics be arranged such that the vowels must always come together. Okay, benda soalan yang sama. Okay, cuma ini optical, ini mathematics. Okay. And then yang ni, yang ketiga, how many 3-letter words can be formed out of the letters of the word logarithms, okay, if repetition of letters is not allowed. Okay. Okay, ini tak sebut apa ke apa, okay. In how many different ways can the letters of the word judge be arranged so that the vowels always come together? Okay, so itu satu lagi bentuk lah ya, bentuk soalan. Okay, dalam task rasanya tak ada yang bentuk macam tu. Okay, you can screenshot this one first. Okay, maybe later on Thursday. Okay, Thursday saya akan exercise sikit on the permutation. Lepas tu baru kita masuk combination. Okay, boleh ya? So this one cuba buat dulu. Okay, we will discuss on esok tak kan Rabu. So we will discuss back on Thursday. Okay. Cuma yang exercise yang saya upload dalam apa tu? Padlet tu itu untuk chapter 1 lah. Untuk chapter 1 kiranya kita dah conclude, kita dah habis chapter 1. So that is for your own ataupun group exercise lah. Fahaman je lah, nak tengok faham ke tidak lah dekat ni. Okay. So this one just be prepared for our next class. Boleh ya? Okay.
Doktor, sorry banyak tanya. Kalau untuk additional exercise tu kena upload juga ke kat Padlet? Working day?
Yang mana? Yang saya bagi dalam Padlet tu kah?
Ha.
Yang dalam Padlet tu upload balik dalam Padlet.
Okay.
Yang ni tak payahlah, ini kita buat individual lah, individual. Cuma saya akan bincang balik dia punya jawapan untuk next class lah.
Alright.
Yang dalam Padlet tu nanti saya akan go through lah, group by group. Mungkin saya akan tanda di situ and then upload balik lah dalam Padlet tu.
Okay.
Yeah? So tapi tak adalah fix yang I'm not sure lah whether you have ada apa tu assignment ataupun apa-apalah yang subjek lain. So kalau tak for first week ni I'm not sure lah, kalau tak banyak kerja bolehlah try cuba this week and upload balik lah. But if have ni maybe lah next week. Tak rush lah. Okay. Anything try to do it before the first test lah, of course. Before the first test one tu adalah apa? 8 Jun kan test one. Okay. Boleh? So this one cuba buat dulu, nanti kita discuss on class on Thursday. Okay. So I just stop. Dah dapat soalan dia? So I just stop sharing here. Okay, so